Okay. All right. So we're going to start with these two theorems, okay? And I don't necessarily expect you guys to be able to understand what they're talking about right away, all right? Because what we're going to do is we're going to take these theorems and create a formula, okay? So let's kind of dig into them. So what this first theorem is saying is we have the altitude theorem, geometric altitude theorem, okay? So it starts off with the altitude drawn to the hypotenuse of a right triangle separates the triangle into two segments, okay? So here's what I want us to do, all right? I think I want us to start drawing that first. So what I'm going to do is I'm going to draw a right triangle so that this segment right here is my hypotenuse, okay? So go ahead and envision that right triangle like that. I think I'm going to have to extend that hypotenuse a little bit. Okay, and then let's go ahead and mark your right angle. So this is the original, all right triangle, okay? But what it's saying is that the altitude is going to be drawn to the hypotenuse of that right triangle, okay? So we're going to go ahead and draw in our altitude. So what I'm going to do is I'm going to label, okay? So this segment right here that I just drew is my altitude, and I'm going to call that alt, A-L-T. Okay, so then what it says, though, is that altitude, all right, separates the hypotenuse into two segments, okay? So the two segments that we're looking for, are looking at, are this segment right here, and then this segment right here, okay? So what I'm going to do is I'm going to label those as well, all right? And it doesn't matter which one's which, but I'm going to call this segment 1, and then this one's segment 2. So seg 1 and seg 2. Okay. So we have this idea in place right here, okay? So then it says, though, is that the altitude is the geometric mean between the two segments, okay? So let's just go back real quick and remember what's going on with the geometric mean. So what we were saying is that the geometric mean has to be on the bottom of one and has to be on the top of another, okay? So we're going to use this idea and we're going to write a formula, okay? So what I want you to do is remember that the geometric mean is in the form of a proportion. So I'm going to have you just sketch out the original format of a proportion, which is fraction over fraction, or fraction equals fraction, okay? But I'm going to make it kind of big because we're going to be writing some lengthier stuff here. Okay, so what it's saying is that the altitude is the geometric mean between the two segments. So what that means is that I'm going to have the altitude on the bottom of the first fraction, and then the altitude on the top of the second fraction, okay? Because it says it's the geometric mean, so it has to be the bottom of one and the top of the other, okay? But then it says it's the geometric mean between the two segments. All right, so remember that the hypotenuse is split into two different segments, so then this top one is going to be segment 1, and it doesn't matter which one's which. All right, and this one is segment 2. Okay, so that's our first formula, all right? The geometric mean of the altitude theorem is segment 1 over altitude is equal to altitude over segment 2, okay? All right, so here's what I want you to do. For this next picture, all right, I actually want you to copy and paste our picture here, and we're going to put it in this box right here. Okay, so it starts the exact same way. So it says the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments, okay? So once again, that's what we have. All right, we have the altitude drawn to the hypotenuse of that original triangle, and it splits the segment or the hypotenuse into two different segments, okay? All right, so we're now going to label some more stuff, though, because then it says that the leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to the leg. Okay. All right. So here we go. I want you to go ahead and label that this full segment right here, all right, all of this is the hypotenuse. Okay. Now, the other two sides of that right triangle are called the legs, all right, and you have two legs. So what I want you to look at is look at the fact that we labeled, all right, this segment right here, segment 1, okay? This segment right here that's right beside it, this is a leg, all right? And because it's adjacent to segment 1, we're going to go ahead and call this leg 1. And when I say it's adjacent, it means that they're touching one another, okay? All right, let's look at this one right here. We call this one segment 2, all right, which means that this leg right here that's adjacent, all right, to segment 2 has to be leg 2. Okay, so we're only going to write one of the formulas, all right, because technically we have two different legs, okay, one for leg 1 and one for leg 2, but the formulas are the same. It's just you have to make sure that you're matching up leg 1 with segment 1 and leg 2 with segment 2, okay? So let's go ahead and write our formula. So once again, it's a geometric mean, which means that it's going to be in the form of a proportion, okay? And it says that the leg is the geometric mean between the hypotenuse, okay? So I'm going to just go ahead and write it for leg 1. So we're going to do leg 1, okay? So it says then that the leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to the leg. So we're going to go ahead and label this top one hypotenuse. I use hype, okay? And then the segment, all right, that we have to pick has to be the one that's adjacent to leg 1, which is segment 1, all right? So then we're going to use seg 1, all right? So this formula is hypotenuse over leg is equal to leg over seg. Okay, so what I'm going to do is we're now ready to start applying this, okay? And I'm going to copy and paste both of these and put them on the top here so that I know these are the formulas that I'm using, okay? So let's take a look at a picture. So we have this full right triangle, okay? And so let's just label what we have, all right? So what is this segment right here? Well, this is our altitude right here, okay? So this is our altitude. So that means we're going to have to find our altitude, okay? The Z, let's go ahead and call this leg 1. It doesn't matter which one, okay? And let's call Y leg 2, okay? Let's take a look at what's going to be our full hypotenuse, all right? It's not shown here exactly, but we could find it because if we add the 20 and the 5 together, our full hypotenuse is 25, okay? So that's our hypotenuse, okay? What are we going to label our 20, all right? Well, 20 is one of the segments, all right? But it is adjacent to leg 1, so the 20 is going to be our seg 1, which means that our 5 is seg 2, okay? So let's go ahead and let's start with finding x. So x is our altitude, right? So if you look at these two formulas, which of these formulas are we going to use in order to find our altitude? All right, the one with the altitude in it or the one without it? Well, obviously we're going to use the one with it, okay? So to find x, I'm going to set up my proportion. All right, and x is going to go on the bottom and then on the top, okay? And then the other one are the two segments, all right? So segment 1 we labeled as 20. All right, segment 2 we labeled as 5. And now we cross multiply. All right, so we do x times x, okay, which is x squared, equals 20 times 5, which is 100. You square root that, you get x is equal to 10. And that's my final answer. Not bad, right? Okay, let's try our next one. Let's find y. Okay, so y we labeled as leg 2. So let's take a look. All right, if we're trying to find a leg, which of these formulas are we going to use? Well, we're going to use the one that has the leg in it, right? So let's go ahead and set up our proportion and let's start filling it in. All right, so the leg that we're trying to find is y. So we're going to put a y here, okay? What's our full hypotenuse? Well, we found that that's going to be 25, okay? And then what's the segment that is closest to y? All right, that's 5. Okay? All right, so cross multiplying, you're going to get y squared is equal to, I believe that's 125. All right, and then if you break that down, because you're going to get y is equal to the square root of 125, and you can't keep it like that, all right? So remember, if I'm going to go over this one more time, all right? 125 breaks down into 25 times 5. 25 breaks down into 5 times 5. Bring down your 5. Okay, remember we're looking for doubles. So I see a set of 5s. I'm going to box them in. I'm going to bring 1 out. That other 5 doesn't have a buddy, so it goes back underneath. So your final answer here is 5 root 5. All right, we have one more to do. We have to find our z. So these questions are a little bit lengthy. Okay, just to save some space here. Okay, all right, let's find our z. So our z, I'm going to just set up a proportion because we know we're setting up a proportion. Okay, so our z is another leg. So which formula are we going to use? We are going to use the leg formula. All right, so I'm going to put a z where my legs are. Okay, all right, full hypotenuse is 25. All right, the segment that's closest to the z is 20, because that's segment 1. And now we cross multiply. So we're going to get z squared is equal to 500. Okay, and then if we break that down, you're going to get z is equal to 10 root 5. And that's your final answer as well. Okay, now the thing is that these don't necessarily change. Okay, the only thing that is kind of different is the fact that like what you're given. All right, so let's go ahead, and I think I want to try a different one. Okay, let's come and do, I know it's on the you try, all right, but I think I want to do this one right here. Okay, and we'll actually do that when we come back, all right, because I think I'm running long on this video.